Alright, so before we get started in division, let's do a little bit of review about what we've learned so far. Alright, because it's been kind of a lot, so let's kind of take it back to some basics here. So letter A, represent 6 to the third as an extended product, do not evaluate. So that's asking us to extend that exponent, so it just wants us to show that 6 to the third is really 6 times 6 times 6. Alright, letter B. If f of x equals 2x to the third plus 7, then f of negative 1 equals, and I put this in here because I just want you to remember that this means that you plug in. It's going to come up several times, and I just want to make sure that we're using that notation occasionally. So this means you plug in for x, so wherever you see x, you're going to replace it with negative 1. When I plug that in, I'm going to use parentheses. Okay, and now I'm going to simplify. Negative 1 to the third power is negative 1. 2 times negative 1 is negative 2. And negative 2 plus 7 is 5. So f of negative 1 equals 5. All right. Letter C. If x to the third times x to the 5 is written in the form of just x to a number, meaning we just want one x and one exponent, then what would that value of the exponent in be? So this is a very, very fancy way of saying simplify x to the third times x to the fifth. So when we multiply, remember we add these two numbers, so 3 plus 5 is 8, so the value of n would be 8. It's a very fancy way of asking us what that exponent would be, okay? Letter D, if the expression 5x squared raised to the third power is written in the form ax to the b, which this is asking us to simplify it to just having a one base, one exponent, and one coefficient, then what is the value of a plus b? So once we simplify this, then it's asking us what happens if we add the coefficient and then add the exponent. Okay, so I'm going to rewrite this, 5x squared to the third power. I'm going to put my little 1 in front of the 5 and then distribute. So I get 5 to the third power, x to the sixth power. 5 to the third power is 125, x to the sixth power. So now I know that 125 is my a and 6 is my b. So that means that a plus b is going to be 125 plus 6, so it equals 131. Now this is not something I'm going to put on a test or mastery. It's just a really fancy way of saying, look, can you use the power rule and then kind of look at what your answers are, okay? And the last one just says rewrite the product as an equivalent expression. So this is one of those ones that's a little more complicated. Remember to put your little ones here in front of your coefficient, and then you distribute your exponent. Oops, I drew that wrong. Distribute your exponent. Okay, I'm going to do this one in a different color. Okay, so I've got 3 to the second power. That takes care of that. X to the fourth power. That takes care of that. Now I have 2 to the third power, because 1 times 3 is 3, and then x to the 15th power. 3 squared is 9, 2 to the third is 8, and then 8 times 9 is 72. X to the fourth times x to the 15th, remember you add those exponents, so you get 72, x to the 19th. So this kind of covers a lot of what we've done so far this unit, okay? So, with that said, we're going to move on to now talking about division. We've talked a lot about multiplication with monomials, which is what these terms are, but what about dividing terms that look like this? Okay, so let's take a look at this expression, 2x to the fifth, 4x to the second, and I'm going to show this to you by expanding it. So what I mean by expanding it is I'm going to write this out without exponents. So I've got 6 x's on top, I've got a 4 and 2 x's on bottom. Okay, now I'm going to look at the numbers separate from the letters. So I'm going to take a look at 2 and 4. 2 over 4 looks like this, 2 divided by 4. And we want to reduce this fraction to 1/2. Now, anytime you're unsure about fractions, and this is going to come up a lot in this learning target, you can always use your calculator, and I really hope you guys have the TI-83 or TI-84s, because when you put 2 divided by 4 or any fraction to your calculator and you get a decimal, you can hit math and then enter again and get that 1/2. Okay, and that makes this learning target a lot easier because you're going to be expected to reduce those fractions. So when I continue writing my answer, I'm going to put an equal sign here, draw my fraction line again, put a 1 up top and a 2 on bottom. It's 1/2, right? When I look at my x's, I need to remember a really important rule. Anytime you have, so I'm going to just cross that off for a second. Let's say I have something like 3 divided by 3. That equals 1, right? How about -2 over -2? Also equals 1. So what would x divided by x be? It equals 1. Anything divided by itself equals 1. So when I look at this problem, I can say, okay, this is x divided by x, cancels out. This is also x divided by x, cancels out. Does anything else cancel out? Nope. I've got 1, 2, 3, 4 x's on top, so now I've got x to the 4th on top. To rewrite, I'm going to leave it like this for now, so we can kind of get a good sense of what we're working with, okay? So this is how we simplify that expression, okay? Let's take a look at another one, and we can kind of try and see if we have a pattern later, okay? So for this one, this is 2x squared. So remember, you put your little 1 here, put your 1 here, and distribute. Oops, sorry. So 1 here, and then distribute. So you get 2 squared, x squared on top. And on bottom, you've got 4 to the 3rd power, x to the 3rd power. Okay? Now 2 squared is 4, and then I'm going to expand the 2 x's. And then 4 to the 3rd power is 64. 4 times 4 is 16. 16 times 4 is 64. And then I've got 3 x's on bottom. Okay? So now I'm going to worry about the fraction first. 4 divided by 64. I don't want to reduce that in my head if I've got a calculator, so I'm going to put 4 divided by 64 in here, hit math, enter, and I get 1/16. So for my next step, I'm going to put a 1 on top and 16 on bottom. Okay, that takes care of the numbers, and then I'm going to cross off. There's 1x gone and 1x gone, so they cancel. Another one cancels, and I just have the x left, and it's on the bottom, so I've got to keep that on the bottom. Okay, so I get this as my answer, 1 over 16x. Okay, so I've turned this thing into this thing. So this took a lot of expanding to figure it out, right? But there's definitely a quicker way, like we've learned before, and we're going to do a few more to kind of, again, see if we can find a pattern. All right, just like we did on the previous learning targets. So the next 3 questions, let's take a look at the pattern. So I'm going to go ahead and expand these out. 5 to the 7th is 1, 2, 3, 4, 5, 6, and 7 over 3 of these. Okay, so there's a cancel, there's a cancel, there's a cancel. So I'm left with 3 5s on top and nothing on bottom. When there's nothing on bottom, you just leave it, because that's an invisible one. We don't put anything. Now, if there's nothing left on the top, and that's going to show up here, we need a placeholder. So I've got 4 x's on top and 10 on the bottom. See how annoying this is to have to write all these out? That just takes so much time. So this cancels, this cancels, this cancels, this cancels. Now, when everything cancels up top, you've got to write a 1 there. Okay? Because now you're telling the world that these leftover x's are now on the denominator. Okay? If you don't have the 1 up there, then how does someone know that's a denominator? Okay? That's really critical. Okay? To put a placeholder there. And that's what we call this. We call it a placeholder 1. All right? And then the last one, I know I did not give you guys at all a reasonable amount of space, and I apologize for that. So kind of write it down to the side. So I've got, in fact, I'm going to have to write this down here, I think. Okay, so I've got 4 x's, 1, 2, 3, 4, and 8 y's. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and on the bottom, I have 1 x and 10 y's. Okay, this is a lot of y's. Okay, so we're going to cancel. That x cancels here, but I don't have any other x's to cancel. So there's one y canceled, another y canceled, another cancels, those cancel, that cancels. Look at all the canceling I'm doing, okay? And at the very end of my answer, I've got 3 x's on top, so that's x to the third, and I've got 2 y's on bottom, okay? Now, let's take a look at our exponents and try and see if we have the pattern. So in the first one, I have a 7 and a 3. How does 7 and a 3... Oh, I messed up this. I'm so sorry, guys. Because I'm thinking, how does 7 and a 3 make a 3? But it doesn't. This should be 5 to the 4th. My bad, guys. I wonder how many of you are going to come up and say that before I fix it later. Alright, so 7 and 3 give me 4. That makes sense. How about 10 and 4? Can we do something with a 10 and 4 to get a 6? Absolutely. Can we do something with a 10 and an 8 to get the 2 here? And can we do something with 4 and an invisible 1 to get a 3? Okay, and if you're thinking subtraction, you are correct. For letter A, 7 minus 3 is 4. For B, 10 minus 4 is 6. And for C, 10 minus 8 is 2, and 4 minus 1 is 3. So there's obviously a pattern in subtracting. Now, in terms of where the number falls, we're going to talk about that, but you have to subtract the exponents to get a new exponent. So that's our third law, is called the quotient rule. Okay, and that's saying, look, if we have 2 things with the same base, you just subtract the exponents. Okay, so you're going to simplify any products or powers. We're going to talk about that next. Then you subtract the exponents with the same base. So, in a proof, I'm going to show you a proof mathematically here. That says 4 to the 7th, so I'm going to show you that, look, 4 to the 7th is going to give me 16,384, and 4 to the 5th is going to give me 1024, and when I divide those, 16,384 divided by 10,024, I end up getting 16. Now, if I do the shortcut way and do 7 minus 5, I end up getting 4 to the 2nd power. Is 4 squared 16? Yes. So, that again, that's not quite a proof, but it's going to show you that there is a shortcut way that we can work this math out and not take up so much time drawing 10 x's or 10 y's. Okay? So, let's try and do some of these problems with just the shortcut and not having to expand anything. So, how my process looks is whenever I see the fraction line, I redraw my fraction line. It's the first step. I don't even look at the math. Then I think, okay, what's 4 divided by 2? That's the same thing as 2 over 1. How about v to the 8v over 2? I subtract 8 over 2. So 8 minus 2 is 6. But does the 6 go here or does the 6 go here? And my rule is that you put the letter wherever the bigger exponent is. So actually, instead of using letter, let's say base or variable. So the variable goes wherever the bigger exponent was. So the bigger exponent in this case is 8. So when I put my v to the 6, I'm going to put it up top where the 8 is. I don't like that answer, though. I'm going to write it like this without the invisible 1. Okay? Alright, number 2. I've got x over x to the 6, 2x to the 6. I'm going to write my 1 in, draw my line. So the 2 doesn't simplify with anything. There's nothing for it to simplify, so it stays in the bottom. And then 6 minus 1 is 5, but the 6 is bigger, so the 5 is going to go on the bottom. There's nothing up top, right? And so remember how I told you to put a placeholder? You've got to put that placeholder 1 up there. Okay? That's going to come up a lot. The second problem. Okay, we've got 8 divided by 2, which is 4, over 1. We've got the x, again, with these longer ones, I cross them out. X to the 7th and x to the 4th gives me x to the 3 when I subtract, but the 7 is bigger, so I'm going to put it on the bottom. Cross those off. And then 9 minus 6 is 3, but since 9 is bigger, I'm going to put it on top. You don't have to put the 1 here. You can erase that if you like. Alright, one with 3 variables doesn't change what we do. It just makes the problem a little bit longer. So 4 divided by 6. This simplifies to 2 over 3. When we reduce that fraction, I'm going to cross that off. Now let's subtract the p's. 7 minus 7 is 0, and it's the same thing on top of the same thing, so I just cancel them out. Whenever I see the same exponent over the same exponent, they're gone. I don't even worry about it. The next letter, Q, we've got a 7 and a 2. 7 minus 2 is 5. The bigger number's on top, so Q to the 5th goes on top. And finally, the R's, I've got 6 minus 4, but the 6 is bigger, so that R squared goes on bottom. So that's my final answer. Okay. I want you guys to pause the video and try these 4 on your own, and when you unpause, I'll show you the solution. Alright, here are your solutions. Please check your work, and if you're watching this video in class and you get the wrong answer, come on up and we'll work it out together. Okay? So now let's step up the difficulty. And I don't want you to panic, because panicking doesn't help. I want you guys to follow a process, okay? So you've already learned the other 2 rules. Now you're just putting that together with this new rule. So you've got 3 rules to think about, okay? So you want to simplify your numerator and your denominator first. So what I like to do is I like to put an equal sign and a line, because I know I'm going to leave the top and bottom alone for now. Okay, so I'm going to go ahead and simplify the numerator by doing that, distributing the 3. So on top I get 3 to the 3rd, x to the 6th, and on the bottom I get 9x to the 4th. I'm going to draw another equal sign and another bar. 3 to the 3rd power is 27, x to the 6th, and on bottom is 9x to the 4th. And now I can go ahead and use my quotient rule. 27 divided by 9 is 3. And x to the 6th, x to the 4th gives me x squared on top, because the 6 is bigger. And so when I write my final answer, I'm not going to put that line there. I'm just going to put a box, because I don't need that bottom placeholder. Okay. All right, number 2. I'm going to go ahead and do the same thing I did in the last problem, only now I have to do it on both of these. So on the top, I get 5 squared, x to the 4th, y to the 6th. And on the bottom, I get 10 squared, x squared, y squared, because all of those have an exponent of 1. When I simplify the top, I have 25 x to the 4th, y to the 6th. And on the bottom, I have 100 x squared, y squared. 27 divided by 100 is 1/4. So I'm going to put a 1 on top and a 4 on bottom. And then I'm going to cross them off. X to the 4th divided by x squared, well, 4 minus 2 is 2. 4 is bigger, so the x squared goes on top. Cross them off. And then the y's. 6 minus 2 is 4. The 6 is bigger, so y to the 4th goes on top. And I'm going to rewrite this a little nicer so it looks kind of even. X squared y to the 4th over 4. Look how many steps that took me. If you're doing stuff like this in your head and you're not doing it step by step, I do not have sympathy. Okay, this is the kind of work where you've got to really show each step and think about each part of the problem. Alright, number 3, the top is going to be x to the 16th, because I'm going to multiply. On the bottom, I keep that 2 right here, but then x to the 4th and x to the 6th is going to give me x to the 24. Okay, and with my fraction, 2 stays on the bottom. 24 minus 16 is 8, but since 24 is on the bottom, that 8 is going to go on the bottom. I have nothing up top, so I put that 1 in as a placeholder. Okay. Now, this one looks scary, but it's not. Okay, we're going to go ahead and just what happens here is that you've got 2 options. One, you can go ahead and move that 5 to every single thing in here. That's what I'm going to do. So I'm going to put the 1 here for the x, and I'm going to draw my line. 5 goes to every single one of those exponents. Okay, so on top, I'm going to have x to the 5th, because 1 times 5. Then I'm going to have y to the 20th. I'm multiplying all these. I'm going to have x to the 35, x to the 10th, and y to the 10th. Okay, now on the bottom I've got 2 x terms, so I'm going to leave the top alone, but the 2 bottom x terms become x to the 45, and the y just stays y to the 10th. And now I can go ahead and subtract. Draw my line. 45 minus 5 is 40, and that goes on the bottom. 20 minus 10 is 10, and that goes on the top. Not so bad, right? So the last level, which you guys are going to really hate, and I'm sorry, I'm just going to apologize now, is negatives, okay? Negatives just are frustrating and difficult. I'm going to say if you want to pause right now and take a little break, you can. These next few problems will probably take maybe 8 to 10 minutes. It's going to be kind of a long video. So if you want to take a pause right now, go get a snack, get a drink, go take a little walk, go to the bathroom, cool, go ahead and do that now. I'm going to go ahead and finish this up, so if you want to stay with me, cool, but you're welcome to take a break, okay? So with negatives, you just have to be a little more careful, right? When I have this -1 here, remember I told you guys to put that in parentheses and put the 1 here, and then you distribute. That's still the same process we have to do, only you're just going to do it with a numerator and denominator if it applies. So in this one, I'm going to have -1 to the 7th, and then n to the 28th. And on bottom, I get n squared. -1 to an odd number is always a negative, so this becomes -1, and 28 minus 2 is 26. So I get -1 n to the 26, which let's just write that without the invisible one. With a problem like number 2, where you've got this weird negative in the front, what I like to do is I like to cross it off, make it go away, and then attach it to the numerator. That's how I like to handle that. There are other ways, other teachers teach different things, but that's how I like to do it. So then I'm going to put my equal sign and make that -2y. And on the bottom, I'm going to go ahead and do the power rule here. Distribute that 5. I get x to the 25, y to the 30. Draw my division symbol. The -2 has nothing to simplify with, so I'm just going to keep it up top. But this 30 and this y has an exponent of 1, and 30 minus 1 is 29. Now the 30 is bigger, so I'm going to have y to the 29 on bottom, and that x to the 25 just stays there because it is all alone and has nothing to subtract. Okay, so really the same idea, it's just you've got a negative to deal with. Okay. All right, the next two problems. Same thing with this one. We're going to take the negative, scratch it out, and attach it up here. So I'm going to go ahead and rewrite that up top because I can't do anything else right now. I got to deal with the parentheses on the bottom. I've got a negative down here as well, so put that sucker in parentheses and put the 1. So you're going to have -1 to the 8th, x to the 64, and y to the 56. When we simplify this, I'm going to go ahead and I realize that -1 to the 8th, that's just a +1. If you ever have a -1 to an even exponent, it's positive. A -1 to an odd exponent is negative, so whenever I see a -1 to an even exponent, I know it's just a +1 and goes away. All right? So on top, I've got -x to the 5th, y to the 4th. Bottom, I've got 64 and 56. So now I can go ahead and leave that negative up top and subtract the 64 and the 5. Well, 64 minus 5 is 59, and that's going to go on the bottom. And then cross them off, you're done. And then 56 minus 4 is 52, and that goes on the bottom as well. Now, there's nothing left on top except this negative, but I'm going to put a placeholder, so I get -1. Okay, and that's my final answer here. All right, number 4. You guys are doing great. I know it's a long video. You're doing awesome. Okay, same thing here. Subtract that little negative and attach it up top. And I'm going to go ahead and do this. See how I've got 2 k's? I can combine those by adding the exponents, right? And I'm going to move this 2 to the front. So I'm going to have -2, boom, boom, that's taken care of. And then k squared times k squared, add those exponents to get k to the 4th. That's my numerator. On the bottom, I'm going to go ahead and do this parentheses in here. So I've got 2k to the 5th raised to the 7th. Keep the top the same for now because we got to deal with this parentheses situation. The 7 gets distributed to each thing inside. So I've got 2 to the 7th and I've got k to the 35th. Okay. I'm going to go ahead and deal with these numbers. So 2 to the 7th is 128. I'm going to cross that off and put 128. And then I've got -2 on top and 128 on bottom. So I'm going to go ahead and use my calculator for this. -2 divided by 128 gives me this decimal, but because I've got my calculator handy, I can turn that into -1 over 64. So when I write my new answer, I'm going to have -1 on top and 64 on the bottom. Okay, so that takes care of my numbers. Cross them off. Goodbye. Okay, now I just have the k's left. 35 minus 4 is 31. The bigger number's on bottom, excuse me. So I've got k to the 31. And that is my answer for number 4. Okay. All right, number 4 and 5. 5 and 6 are our last ones. So for this problem, I'm going to distribute this 8 to everything is first. I've got a 1 on the B, a 1 on the A, and this little sucker is a -1. I've got a -1 here, so I'm putting parentheses. I know it's kind of hard to see on my screen, but I've put parentheses around the negatives and I've put my invisible ones. So when I distribute this 8 to every single term in here, I've got an exponent for it to multiply to. So on the top, I've got -1 to the 8th. I've got then a to the 8th, and I've got b to the 8th, because 8 times 1 is 8 all the way across. On the bottom, I've got -1 to the 8. I've got b to the 5 times 8 is 40. I've got a to the 64, and I've got b to the 16. Now I notice that -1 to the 8th, that's going to be a +1. Same thing, -1 to the 8th is +1. So those two things go away, which is really nice, because now I've just got the letters to deal with. Okay? So on the top, I've got a to the 8th, b to the 8th. On the bottom, I'm going to deal with these two b's together. Okay? When I have them on the same line, I add the exponents. So 40 plus 16 is 56. So I've got b to the 56 and a to the 64. Okay? Now I just subtract because I've got my quotient rule left. 64 minus 8 is going to be a to the 56. And done with my a's. Oh, sorry guys. 56 minus 8 is 48, so that's b to the 48. Okay, everything is gone on top, so put that placeholder 1 right there. Okay. Last one. So I'm going to rewrite the 2a to the 7th, b to the 7th, because I can't do anything yet with that. I'm going to go ahead and take care of this 3 and distribute it to everything inside. So I'm going to have -1 to the 3rd, I'm going to have a to the 3rd, and b to the 6th. Draw my line, and I've got -b to the 6th. Now this looks really crazy. So I'm going to go ahead and make my life a little easier and deal with these negatives. So here's a -1 right here. There's a 2 right here. And this cancels out and just becomes -1. So I like to cancel them out and just circle them all so I can kind of get a better idea. So on the top, I've got 2 times -1, which gives me -2. So boom, that math is done. On the bottom, I've got a -1. So there, that's done. On top as well, I have an a to the 7th and an a to the 3rd. That's going to give me a to the 10th, and then cross it off. Now I've got a b to the 7th and a b to the 6th. That's going to be b to the 13th. Cross it off. Noticing how I'm crossing off as I go so I don't get confused. And on the bottom, I've got that b to the 6th. Well, a negative and a negative cancel out, so that's gone. So on top, I've got 2. The a to the 10th doesn't have a friend underneath, so that just stays. And then 13 minus 6 is going to give me a 7. And everything is gone on the bottom, so I don't need a placeholder. Okay? The trick to this learning target, and truly this unit, is to cross things off, use parentheses, and show your steps, and take it one step at a time. A lot of you have trouble organizing your work, writing neatly, using these tricks, and I'm telling you right now that this unit, you've got to do those things to be successful. Alright, and I'm going to help you every step of the way. Alright? Take your practice seriously, try every problem, and come to me if you need help. Okay?